All right, we will start with law of sines. So the previous lesson we did applications for right angle triangle using the knowledge of sine theta, cosine theta, and tan theta with the ratio and all of that. But the application we did was only for right angle triangle. So the calculations for sides and angles were only for right angle triangle. So my SOHCAHTOA is applicable only for right angle triangle, right? So now we are actually moving to law of sine and law of cosine. For the first time, we'll actually see how we do calculations for non-right angle triangle, because obviously in real life you're not always going to be working with right angle triangle. Right angle triangle is very common because it's the corner and the angle made, but it doesn't mean that that will be the only situation. We also need to know how to work with, the name is called oblique triangles. So oblique triangles are basically non-right angle triangle. So use law of sines and law of cosine, we'll see that also. But today right now we're doing law of sine. Use law of sine to solve for an oblique triangle. So oblique triangles are basically a triangle that is not a right triangle. That's the definition of an oblique triangle. So like I said, we mostly have worked with calculating sides and angles of an right triangle. For the first time, we'll see how to work with oblique triangle. Like we see a non-right triangle, and some of you kind of said, okay, let's use Pythagorean theorem, and I had to stop you saying, no, you cannot do that, because things like Pythagorean theorem and SOHCAHTOA, all those were applicable only to a right angle triangle. So we'll see something a little different here. So let's go ahead and write down the law of sine. What is the formula for the law of sine? So if you for you guys, if you look at the last page of your notes, it contains all the formulas. But I'm going to go ahead and write it down again, and you will be given this formula sheet on your test when you take the test. So law of sine is the first one. So I'm going to go ahead and write this again, and it's not a bad idea to write it, so we can talk about it. How does this formula look like? What does it mean? So it basically uses sine of angles. So it's there in your formula sheet. I'm just writing it down. So we can also talk about what we mean, what this formula actually means. We can actually talk about what this formula actually means. So obviously we are working with an oblique triangle, so I'm no longer drawing a right angle triangle. I'm drawing an oblique triangle. Okay, I'll wait till you guys write this. This oblique triangle, normally when I make the triangle and I mark ABC, those are my vertices or those are my angles. So I use capital A, capital B, capital C for my vertices, or they are my angles. So that's why we say, remember, sine, cosine, tan, they're always followed by the angle. That means this is sine of angle A, this is sine of angle B, this is sine of angle C. And then in the denominator for each of these ratios, there is small a, small b, small c. Generally the rule is that opposite the big alphabet, A is the side A. So this will be side A, this will be side B, this is side B, C, small. So those will be. So small alphabets are the sides, the big alphabets are the vertices, or basically the angle. Vertices is the angle. I'm going to go ahead and quickly write these A, B, C, but you have to, okay, let me write this down, and then I'll tell you why it's not that. There's an easier way to figure out when you can use law of sine. So it tells you can use law of sine in these three scenarios. These three scenarios are two angles and a non-included side. So you're looking at two angles, and a non-included side means a side that is not between the two angles, so you'll write it this way. If you go back to your geometry days, I'm thinking you guys remember when you did things like SAS and ASA. SAS means two sides and an angle in between. So if you put the A in between, it's always in between. Here you're putting the side not in between the two A's. That means it's a non-included side. And then here it says two angle and an included side. So two angles, but the side has to be stuck in between. So ASA. And this one is two sides and a non-include angle. So I don't put the angle in between them, so it's SSA. Okay, so like I said, I'm not a great fan of this, trying to memorize it. It's a little easier when we get to law of cosine, I'll tell you why. But the easier way to remember is when can I use the law of sine. So when you look at it, it is basically the law of sine uses 3 ratios being set up as a proportion. So as long as I have one angle and a side opposite, I'll have one ratio available to me. So if you want to look at your diagram and you want to see, okay, this angle is given to me and the side opposite is given to me, this is a good time to use the law of sine, because I can definitely fill up one side, and as long as I have one of the 2 other sides, I can use my law of sine. Okay, instead of me talking, let's look at it as to where the law of sine is useful to use, and you'll see as you keep doing more problems, you'll start figuring out where to use the law of sine instead of trying to memorize this. Let's leave this alone for now. We could come back to that later. Let's go ahead and do the first one. Solve the following triangle. Again, solve means what? Find all the missing sides and angles. They're given you some, you're going to find the others. Solve the following triangle giving the following information. This is the information that they've given us, and it says round to 3 decimals. That's what we'll do. So let's go ahead and draw the triangle. That's the first thing you want to draw. So I draw my triangle and I mark it as A, B and C. You can, so you can, obviously mark it any way that you want. Just be careful of how you mark it, right? So it says capital B. Capital B means angle B is 45 degrees. Capital C is 95 degrees. And small c is 5. So can we all mark small c? So small c is going to be opposite capital C, which is 95 degrees. So this is going to be 5. What all do I need to find? I need to find angle A, right? I need to find angle A, and I need to find side B. This is my side B because opposite angle B, and I need to find side A. These are things I need to find. They've given you 3 things. You're going to find those 3 things. Okay. Angle A is easy. Do I have to do anything much for angle A? Yeah, go ahead. Perfect, yeah. So basically, given 2 angles, you can always find the third angle in any triangle because they add up to 180 degrees. So angle A is my easiest one. It's knowledge coming from the previous. It's nothing new that I'm learning. So it's 180 degrees minus 95 plus 45 degrees. Go ahead and tell me what that is. 40 degrees, perfect. Okay, all right. Now, how do I find side A and side B? I do have all 3 angles. Okay, so this is where we want to analyze. Can I use law of sine here? So when you look at an oblique triangle, that's the first thing that should come to your mind. Can I use a law of sine? If you cannot use law of sine, then you'll try to see, can I use law of cosine? But in this case, we're going to try to use a law of sine. So can I use law of sine? Yes, I can, because I have one angle and the side opposite to that given to me. I have one angle and the side opposite to that given to me. So what do? I set up. So remember, again, when we set it up, I have the ratio of 3 different angles and sides. For you to solve, you need to use only 2. You can't write down all 3 and solve. You can either write A and B, or B and C, or A and C, or whatever. So you need to write only 2 of the ratios, set up the proportion, cross multiply, and solve. And that's what we're going to do. So one side will definitely be sine 95. So this is your first step. I'm just going to write down, number it so that we know which order we're going in. Then I'm going to do sine of 95 degrees over 5 is equal to. Everybody got this? Okay. I can either solve for B or C. Either one of them works. Either one of them works because I have the angle opposite. So let's say I start with, I don't know, side B. So I will say sine 45 degrees over small b. Okay, so this is a new thing that we're talking about. Is everybody clear about what I just wrote? So you use one side and the angle opposite because both of them are given, and for the other side, for the other angle side combination, you know the angle, the only thing missing is that side. So remember, you can always solve any equation as long as there's only one variable. The only variable I see is b here. The only variable I see is b here. So let's go ahead and cross multiply and solve for it. So what do I have here? B multiplied by sine 95 degrees equals 5 multiplied by sine 45 degrees. Therefore, B is equal to 5 multiplied by sine 45 degrees divided by sine 95 degrees. Is everybody okay with what I've written so far? Okay, I'm going to leave it for you guys to absorb. Before you write it down, take a look at it and see if you understood the statements. Alright, after this is only using the calculator. But please let me know if for number 2 if any of the 3 steps is unclear. Is there anything that's not clear here? So again, you can always use the law of sine as long as you have one angle and a side opposite, because this is set up. The other side, there will always be either one angle or a side that you can use. You write that and solve for it. Can you put your name? Okay. Anyone who wants to borrow a calculator, please. I'm leaving some out, and please just put your name up on the board. That's all. Yeah. Thank you. Did we all get this? Okay. Or if you're still working on it, work on it. See if you can get that for B. Everybody did okay with B? Okay, so now the only thing missing is A. I'll do exactly the same thing. If this is a right angle triangle, I would use Pythagorean theorem. You know, 2 sides, you can use Pythagorean theorem for the third side, but this is not a right angle triangle. So I will use the same concept again because there's nothing else I can do. I still have 95 and C, and then I will use 40 and A. So I'll use the same thing. Step number 3, sine 95 degrees over 5 equals sine 40 degrees over A. Please go ahead and get A by itself. I'm not even going to show the work because I think all of you can do that. Cross multiply, get A by itself, and tell me what you get. Did anybody not get A and wants to see work? I'll be glad to show the work. Now we're good. Can I move to example 2? Okay. Can we all try this ourselves? Let's draw the diagram. Step number 1 is always to draw the diagram and mark all the sides given to you. And think about it. Think about, can I use the law of sine? The fact that this is under the law of sine section, you can, but think about it as to why you can use the law of sine. your diagram looks something like this. Of course, your ABC can be switched around. There's absolutely no rule that this has to be A, this has to be B. You could have started with A at the bottom and gone. So you can obviously switch it around, draw it in any way, as long as you mark B as 35, A as 25, and the side opposite angle C as 4. So can I use the law of sine as is? Not yet. Not yet, right? Because I am given one side. Unfortunately, this angle opposite that is not given to me. No, you can use law of sine only if you have a side and an angle opposite that both given to you. But is it difficult for me to find angle C? Not really. Given any two angles, you can also. So once you find angle C, now then you are set up to use the law of sine. So let's go ahead and find angle C. Everybody okay with angle C? Now, can we all think about law of sine? So now you can use law of sine, right? Because I do have a side and an angle opposite that. So set up your ratio. Remember, you need to use only two. You need only two. So set up your ratio using these two, and then solve either for side B or side C. You can solve either one of them first, and then the other one. So this one will be side A, which I don't know, and this one will be side B that I don't know. I'm going to start with side A, but again, if you already started with side B, totally fine. I'll show both. All right, how's everybody doing? There's my. Okay, take a look to see if you got the right answers. Everybody doing okay? Okay, so there's one thing I do want to talk about. It's just a good. Do you notice that the value of A is smaller than the value of B? And the reason being? Perfect, yeah, right answer. Because this is the smallest angle. This will always have the small. So just something that you've learned in geometry, I do want to make sure that we remember. And this is the next size. This will have the next size, next measurement. And 120 degrees is the largest, therefore it has the largest measurement. So sometimes when you do the work and you find that it's not matching up correctly, go back and look at your work. So those are some of the ways to check if your work is correct. Yeah, all right. Let's keep going. Okay, let's just take a minute or two just to read the problem. Let's take a minute or two if everybody can read the problem. The good thing about this problem is they have given us the diagram. Problems like these, when they don't give us the diagram, becomes tricky. Just to be able to draw it correctly and mark, they've drawn the diagram and even marked the sides for us. So that makes it easy. So let's go ahead and read it silently for about a minute. Okay, everybody's reading silently? Thank you. Okay, this one's a little trickier, and I'll tell you why. So hopefully everybody read it. Also, I think the fact that they've given us a diagram and marked all the sides makes it really easy. Even if I didn't pay too much attention to this, the fact that there's a plane here, there's a carrier here, there's a destroyer here, there's all of that. And more than anything, I think more than the word count, the fact that I have a triangle where I have two sides, 5 kilometers. I'm going to go ahead and write the kilometers so that I know that when I write my final answer, it has to be in kilometers. The two distances are 5 kilometers and 12 kilometers. What I do need to find is I need to find this B. That's what it says. It says how far is the plane from the destroyer. So the B is what I need to find. What I do also have is I have one angle, and that angle is opposite 12 kilometers. The reason why it is a two-step process and not a one-step process to solve for B is because, sure, I can set up the law of sine. I can set up the law of sine because I have one angle and the side opposite that. I can set up the law of sine. But when I set up the law of sine, I cannot solve for side B straight away because both of them are unknowns. Only one of them is allowed to be the unknown when you set it up. Remember, in any equation, you can only solve for one variable. So it will, if I try to solve B right away, it will be sine B over small b. I can't solve for both of them. So what you do is you first solve for A. This is what you first solve for. Because why? Because you have the side opposite that. So you have these two. You set it up using these two. That way you'll have only one unknown to solve for. Once you solve for A, you can find capital B, the angle, and then you find the small b. So let's go for it. So it's a two-step process. Let's do the two steps. So that's a setup for the first one where you're solving for angle A using the 5 kilometers opposite that. Can we all isolate angle A? Or we will isolate sine A for initially. So sine A. Remember, sine and A cannot be separated because A is an input for sine. Sine is a function. Sine existing. So you just have to separate the sine A. And from here you have to get the A, but we'll get to that. Everybody good with isolating sine A? It is 5 times sine 37 over 12. Okay, now how do you isolate? What do you do to get A by itself? Sine inverse. She's absolutely right. So that is where the inverse comes into play. The fact that they cannot be separated, but what I can do is I can move my sine to the other side. If it moves to the other side, it becomes a sine inverse. That's how you separate the angle from the function. So this becomes, what you need to put in your calculator as A equals, angle A basically. Angle A is equal to sine inverse of, so please keep in mind whenever you're solving for an angle, you're always using the inverse. 5 sine 37 degrees over 12. Please put this in your calculator and see what you get. I'm assuming we all, I should have said this before, we all have our calculator set to the radian mode. No, the degree mode, I'm sorry. We're looking at the degree mode, yeah. We're all working with degrees, so we should be set in the degree mode. For me to find side B, I need the angle B when I set it up using law of sine. So find angle B. Now it's possible for you to, can we all check, make sure our value for angle B is correct, and now set up the, again you'll use law of sine because you still have an angle in the side opposite, and yeah, now go ahead and use law of sine one more time to solve for side B. I'll still use sine 37 and 12 as the side that I use, and the other side is going to be okay. Let's solve. So this should be a setup for to find side B. Everybody doing okay? So please make sure you're right. If they give you the angle of a measurement, unit of measurement for something, I need to see it in the final answer too. So the distance from the plane to the carrier is 615, or destroyer, whichever that is, is 15.61 kilometers. Again, I'll be glad to show the work, any of it, explain any of it, you just have to ask. Yeah. Yeah. Does anybody need a little more time for this problem? No. Okay. We do have one more problem, which is example 5. It is a great problem in the sense that it's actually fairly challenging. But what I'm going to do is I'm going to hold off on it. I prefer to introduce the law of cosine, and we will do this as the first problem next class when we are fresh. So we'll hold off on that for now, and let's go to law of cosine.